Hello students, in this video we're going to work on graphs and functions. Now at the end of this lesson you should be able to graph by plotting points, identify the domain and range, the x and y intercepts, and then identify increasing, decreasing, or constant function intervals. In addition, you should be able to determine relative maximum and minimum and end behavior. So let's get started. So the first should be the easiest, as we've done this all in 7th, 8th, and up till now. So the first thing we're going to do in example 1 is graph by plotting. So in order for us to determine how these graphs look, we are going to need to make a t-table and start filling out points. So I always want to pick out 3 points at least. I usually pick out 5, but in interest of this video we're only going to select 3. We always want to pick some that are positive and some that are negative. So you pick -1, 0, and 1. So what happens is when we substitute -1 into the equation, it says -1 squared minus 1. Notice we're literally taking our x value and substituting it into the function, which I'm showing you right now. -1 squared is 1. 1 minus 1 is 0. For the 0, it's 0 squared. 0 squared is 0, minus 1 is -1. And for 1, 1 squared minus 1 is also 0. So now we have our 3 points, and then we're going to plot these points. So for the first one, it says at -1, we're going to start at the origin. It says our x is -1, so we go left 1, and because our y is 0, we don't move at all, so that's where our point is. For the second point, it says 0. 0 means we don't move left or right, and we go down 1. And for the next point, it says x is 1, and y is 0, so that's our third point. Once we have those points, we merely want to connect the dots. So we have a parabola. Make sure you put an arrowhead at the end so we know it goes on forever, and that's your graph. In example 2, we're going to do the same exact thing. We're going to make an x and y table. We are going to select some points, so we're going to choose -1, 0, 1, 2, and 3. So I picked more points this time, but you'll see why in a little bit. So when we substitute -1 in there, it becomes the square root of -1 minus 1, which is really the square root of -2, which at this point doesn't exist. It is imaginary, but we're not going to worry about it for now because we can't graph that just yet. If we substitute 0, it's the square root of 0 minus 1, which is the square root of -1. Again, not going to work for us. So now we have the square root of 1 minus 1, which is 0. Now we actually have things that exist. So the square root of 2 minus 1 is 1. So it's the square root of 1, which is just 1. And the last one is the square root of 3. So I'll do square root of 3 minus 1. That's actually just the square root of 2. So we're going to plot these points again. Keep in mind, this one doesn't help us. This doesn't help us. But the one does. So our x-intercept, or our x value, is 1. That means we move 1 to the right, and we don't go up or down, so that's our first point. The second one is 2. That means we go 2 to the right of the origin, and the answer is 1. And the next point, it says x is 3, so that means we move 3 to the right of the origin, and it's the square root of 2. Square root of 2 is approximately 1.3. We do that, and then we connect the dots following the trend. So that's our answer. Now, if you look at the next line, it says identify the domain and range. So that's what we're going to do. Now, for the parabola on the left, the domain is all real numbers because it goes to the left and to the right forever, because that's what our domain does. It takes care of our x values. The range should always usually start with all real numbers, but in this instance you'll notice that this parabola, if we trace it, so starting here, it's going to go downwards, and it stops right here at -1. That means we have all real numbers where y is greater than or equal to -1. So all real numbers where y is greater than or equal to 1 is our domain and range for the parabola. For the one on the right, the domain is not all real numbers. The domain in this case, again, is all of the x values. So where does it start? So again, we usually do all real numbers where x is, notice if we trace this graph, here at x equals 1, that's the last point we have. That's the farthest left we have. It doesn't go any more to the right. So we say all real numbers where x is greater than or equal to 1. The range is all real numbers where y is, now notice how far down does this graph go? It doesn't get any lower than y equals 0. Above that it exists. So where y is greater than or equal to 0 is our range. The last thing they're asking for here is to find the x and y intercepts. So these should actually be very easy. So we're going to do this in red. So to find the x and y intercepts, again, intercepts just talk about where things cross. So if we're looking for x and y intercepts here, the graph crosses here, here, and here. So to answer our intercepts question, our x intercepts are at x equals -1 and x equals 1. Our y-intercepts are when y equals -1. So to explain that further, we'll notice that as we trace this graph, it crosses the x-axis here. And that value where it crosses is x equals -1. When we do it from the other side, notice that the graph crosses the x-axis again at 1. That's why our x-intercepts are 1 and -1. Our y-intercepts right down here. So it intercepts at y equals -1. So if we do the same thing for the graph on the right, notice it crosses an axis here. And that intercept is an x-intercept because that's the x-axis. So the x-intercept is where x is equal to 1. And since that's the only place where it crosses, that's your only intercept. So we're going to do another practice in identifying x and y intercepts. So this is where it crosses an axis. This is where it crosses an axis again. This is where it crosses another axis, and this is where it crosses another. So our x-intercepts are at x equals -5, x equals -1, and x equals 1. Those are our x-intercepts because that's where it crosses the x-axis. Our y-intercepts, they cross at y equals -3. That's our only y-intercept. For example, 3, let's make points where it crosses. So it crosses right here, crosses right here, 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 and here. So again, we just itemize it. X-intercept is at x equals -4 and x equals 5. I actually made a mistake when I wrote this the first time. It doesn't actually cross right there or there because those aren't intercepts. So your only x-intercepts are at -4 and 5. Your y-intercepts are at y equals -2. And those are the only times it crosses a major axis. So the next part of this says identify the intervals of increasing, decreasing, or constant functions. Intervals tells you when the graph is increasing, decreasing is when the graph is going downwards, and constant means when it's staying the same or it's a horizontal line. So if we take a look at this graph, to denote that we're going to use vertical lines, vertical dashed lines, so that might make it easier to see. So if we trace this graph from here, notice that it stops right about here, and then it changes directions. Here it changes directions again. We do the same thing for example 3. It's going downwards until here. It's going upwards until here. Downwards until here. And that's it. So let's go through these again. For example 2, we know that from negative infinity from negative infinity to negative 3, it's increasing. We also know that from 0 to infinity, it's also increasing. So just to make that a little bit more easy to understand, let's trace it. So from down here, negative infinity, because it's down here, it's going up, 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 and then it stops going up when x is negative 3. And then it goes down, and then right here at 0, when x is 0, x to infinity, also increasing. Decreasing is when it's going downwards. So for this one, it's decreasing from negative 3 to 0. Those are when the intervals are decreasing. Example 3. Example 3, we're looking for increasing only. So it's increasing from negative 1. Notice how we're putting in parentheses, from negative 1 to 0. And from 3 to infinity. Again, taking a look. From negative 1, which is right here on the graph, it's going up from there to here. Then it goes down. And then from 3 to infinity, it's still increasing. If we're looking for decreasing values, we're saying it's decreasing from negative infinity to negative 1. And from 0 to 3, it's decreasing. So again, we're just tracing the graph. Now, the next part, it says determine the relative maximum and minimum. The maximum is when it reaches that peak. The minimum is when it's at the very, very bottom. So look at it as the maximum is like when you're throwing a ball. The minimum is when you reach the bottom of a hill. So we're going to do this in green. I'm going to make this a little bit bigger. We're going to trace the graph starting from down here. So as we follow that track, it goes up, 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 and it reaches a peak right here. Then it goes down, and it reaches a valley right here, the bottom of a hill. Now this point right here doesn't count as a max because it's saying it's going to go on forever. So for example 2, your max is at x equals negative 3. Your min is at x equals 0. So for example 3, we'll trace it again. We're starting here, we're going downwards, and right here we reach a valley, or the very bottom, and then it changes directions again, it goes up. So this is another one right here. Then it goes down again, and there's another valley, and then again here it's going to continue to go up forever, so it's not a max or a min. So let's itemize that. Your max here is at x equals 0. Your min is at x equals negative 1. And x equals 3. And behavior should go by very fast. These are called even functions and odd functions. Even functions should be easy to spot. If we look at y equals x squared, y equals x to the 4th, y equals negative 2x to the 6th, and y equals negative 5x to the 8th. These are called even functions because all of their exponents are even. Odd functions are called odd functions because all of their exponents are odd. The biggest difference between them is what's called their end behavior. Their end behavior is how they look on their ends. So we know x squared. X squared is a parabola, which means its end behavior looks something like this. You have the left side ending up like that, and the right side ending up like this when it works. Okay, and the only thing is it's not showing you the middle, but that's the gist of it. All even functions look like that. So for y equals 3x to the fourth, the second one, it's actually the same exact end behavior. The third one, however, is a little bit different. Because it has this negative 2x to the sixth, it means that instead of it starting where both ends are going upwards, because it's a negative, it means the entire thing gets flipped upside down. So really the end behavior, they're both going in the same direction, but because of the negative in front of the x, it means it's going downwards. For the last one, it should be the same thing. They're both going the same direction, but they're going downwards. Odd functions, a little different. They're not going to end and start the same way or go in the same direction. Because they're odd, they're going to go in different directions. So y equals x cubed actually means it's going to start going downwards, like so. And on the other side, it's going to go upwards. So complete opposite directions. So the next one should be very similar. So for the next ones, we're going to have one going downwards, like so, and then the other one's going to go upwards, just like the others. In y equals negative 2x to the seventh, because there's a negative in front, everything gets flip-flopped, remember? So what's going to happen here is that because it's a negative in front, instead of going this way like everything else does, it's going to be flipped. That's all it is. Let me do that right. That means this is going to go upwards instead of downwards, and this is going to go downwards instead of upwards. For y equals negative 5x to the 13th, it's the same exact thing. Again, because we're only talking about the end behavior, we don't care about what's happening in the middle. So that's all for now. Try solving these two problems and all the various parts, and we'll take a look at it in class tomorrow. That's all for now. See you guys next time.